Hello, good morning, ma'am.
Good morning, how are you?
So, ma'am, we are waiting for some more participants to join. In another 5 minutes, we can start.
Wonderful. I will have to stop Dr. Priyanka at past, but otherwise you have me wholeheartedly.
Hi, Dr. Katina. This is Dr. Priyanka.
Hello, Dr. Priyanka. How are you?
How are you doing?
Very well today. Thank you very much for asking.
Thank you, and thank you so much for joining.
It's a joy. Thank you for the invitation.
Pleasure.
Good morning. Chalo, all the best.
Yeah, do you?
A very good morning to all of you. So we have with us today Professor Dr. Katina Michelle. She is a professor with Arizona State University and a senior global future scientist with the Global Futures Laboratory, with a joint appointment in the School for the Future Innovation in Society and the school she was employed with Nortel Networks, Anderson Consulting, and OTS Elevator Company. She has been funded by the National Science Foundation, the Canadian Social Sciences and Humanities Research Council, and the Australian Research Council. She is the director of the Society Policy Engineering Collective and the founding editor-in-chief of the IEEE Transactions on Technology and Society. She has been a technical editor and the editor-in-chief since 2005 and for several publishers. She is also the founding chair of the inaugural Master of Science in Public Interest Technology. So today, as a part of our Global AI Summit, which is a 3-day-long conference, which is hosted by the School of Computer Science, Bennett University, we are privileged to have ma'am today for a keynote session. And her topic will be unleashing the wrong kind of AI when human decision makers fall short. So this is a very, very relevant topic in today's world where we are seeing a lot of use of AI. And in that case, how ethics and AI responsibilities to be taken. So thank you, ma'am, for taking time out of your busy schedule and talking to us. So we have our students which have joined us in and many of them have joined in the online mode also. So I welcome you again, ma'am, on behalf of Global AI Summit. And over to you, ma'am. Thank you so much.
Thank you so much. There is a bit of an echo. Perhaps we'll just wait. Okay, very good. I'm going to say a warm welcome to everyone and assume you can hear me and you can also see my slides. I love invitations from the Indian community and colleges and universities in India. I have traveled to your beautiful country so many times and always come back inspired. So to see a room full of students is again inspiring, and I'm grateful that you also have given of your time to hear this important topic on artificial intelligence. And today we will focus on the socio-technical, the social being, the responsibility of the human being in decision making. And perhaps when we look at some artificial intelligence software, systems, or features, whether I'm so sorry, I can still hear the echo. Here we go. Whether we can make some definite understanding of what is going wrong in the deployment and delivery of these advanced systems, remembering that AI is not a singular technology, it's not just machine learning, it's the conglomeration and convergence of so many different technologies, including big data, Internet of Things, cloud computing, and so much more. The presentation I'm going to deliver today will be a short presentation, and the inspiration for that presentation came from a paper we edited together with Jordan Richard Schoner from Canada, now in the US, and Professor Kathleen Vogel, a colleague of mine at Arizona State University. And we called this paper Failures in the Loop, Human Leadership in AI-Based Decision-Making. And it appeared in the March issue of the Transactions on Technology and Society. So failures in the loop. We often talk about humans in the loop, but where is the source of failure is the question. Often we will start to look at the dark side of AI, particularly with talks that look at what is the root cause of negativity around artificial intelligence. And often we're shown these kinds of images. They're quite dark. Robots are ruling the world and ruling humans. This interplay between society and humans, humans turning into machines. And these are the kinds of images that we portray when we talk about the dark side of AI. But what about the light side? What about the benefits? And how do we achieve those benefits through human intervention, through humans in the loop, in the decision-making process of what kinds of AI we are going to build? So AI's design, development, and deployment requires assessment. And when we're going through these stages in industry or in academic research or government agencies, we start to ask motivating questions. What is the motivation behind the development of the AI? Is it monetary? Is it purpose-driven? Is it about meaning? And independent of which one of these things and many other options there are, many alternatives, we need to start looking deeper into what is the essence of the AI we are trying to build. What's the point? Is it simply profit maximization? And it shouldn't be. There should be other factors, whether they're external or internal factors. Maybe they are linked with the Sustainable Development Goals. Maybe they're linked to ethics, sustainability, and governance, or some kind of compliance standard or otherwise. The other question we might have at these stages of development and design and deployment is, where is the responsibility that we're going to look at, for initiating the project, for actually conceiving and going forward? We call it a go decision. For monitoring the ongoing nature of the AI and how it's actually there deployed in the world, and then regulating its development. And all of these things are important. So who begins the process? How do we monitor the process through design, development, and deployment? And then how do we regulate that development? How do we standardize that? And we have guidelines through the IEEE and many other organizations today that are talking about standards towards the development of AI software or systems or services that actually follow some form of benchmarking. And we should be using these as guidances. We also might be thinking about the characteristics of group decision-making processes. Who's involved? Are users involved? More than the software developers involved? Are more than senior management involved? Do we have regulators at the table? Have we conferred with government agencies that may have something to do with the service that we deploy? So it's not simply a single entity that is making a decision. It's a process that engages multiple stakeholders and brings them together to make a nuanced decision about an AI's design, development, and deployment. We also may talk about how values and risk management have been incorporated into the stages of development. Do we know what the organization's values are? Have we embedded those values in the design process? And what kinds of risk management do we adopt? And then the responsibility for continual monitoring to make sure that following implementation in its operational phase, there is some oversight over how the AI is behaving. Is it accurate? Is it causing problems to users? Is it flowing well? And are people adopting it and understanding its shortcomings, if any? And then a particular point, we talk about decommissioning physical hardware, but in this instance, we may be de-implementing an AI if applicable. We may be saying this is the end of the lifetime of the AI because of advances in technology and new convergences, but also limitations of the existing, perhaps, methodology that was adopted intrinsic to the machine learning or deep learning or other kind of learning. So we talk about AI's non-violation. And I want you to think about this. Imagine this was a piece of software and it was an artificial intelligent piece of software. Well, if I left it on my computer just there, my hands are up without it, it can't choose to do something. It doesn't have legs. It doesn't have feet. It really doesn't have a brain to think independently. Yes, it can be trained on existing data sets. It can be trained to be somewhat dynamic as things change. It becomes adaptive, but it really doesn't have its own spirit, its own volition, as we say. So it's non-violation to a point. Choice requires that there are alternatives, that these alternatives are perceived and understood, that appropriate resources are available to realize these choices, and that a decision maker is autonomous. It's a human. So humans remain accountable for choosing to develop, adopt, or shut down a system. You know, when the AI misbehaves, we can't say, naughty AI, you know, you have made some trouble for so many people. It's usually the finger pointing is at a human who had initiated the process, the software developers who created the artificial intelligence system, service, or otherwise, and went forward into its operation to actually create a revenue stream. So any claim that humans are out of or on the loop ignores the fact that a choice was still made to initiate the loop, and that humans are the sole agents who can understand the meaning of what occurs in the loop, right? So a human being had to begin the process. So human decision makers cannot be absolved from their obligations to users, to consumers, to citizens, with a rhetorical device of calling a system an autonomous agent. Just because this thing that I hold up could be an autonomous agent one day, it doesn't mean that the human says, look, it's not my fault. I blame it on the autonomous system. The autonomous system is non-violating. The human being behind it and the group of people behind it usually are the ones responsible for violation, even if the AI misbehaves in ways that the human did not expect. We have this wonderful quote from 2020 from Tigard et al. And they say, we often speak and act as though we are blaming or praising our technological devices like the Apple iPhone or the Samsung device or the Samsung smartwatch. Despite these practices being unfitting toward artifacts, we really can't blame an inanimate object like an artifact. We are perhaps saying that responsibility lies not even with the organization, but within individuals in an organization that are responsible for either the initiation or the development of a piece of autonomous system. So we talk about corporate accountability here. Despite organizations being viewed as entities in the law, employees or leadership are held accountable when successes or failures occur. The idea of corporate personhood is essential. So there is the corporation. It is a legal entity, but who is within the corporation? We can't just blame everyone at company X because not everyone built that particular AI. So then we're seeing a change, gradual change occur with individual employees or groups of people being held responsible and accountable when things go wrong. But as many hands are involved in making the AI, allocating blame is not an easy task. Where did it happen? Where did that system go wrong? And moreover, while the brand of an organization might remain relatively stable, those behind the brand change. So, okay, the entity exists, but tomorrow there's this leader and the day after that leader, and we don't know when the decisions were made unless these decisions are recorded. And what we are advocating for in this paper is what's called a socio-technical risk register, which identifies decision-making processes, when they were made, who was consulted, what they said, and what things are risks that are tolerable risks. We can survive with those risks. The company won't be in debt when someone points the finger at something potentially going wrong. But then there are things that are intolerable, and those risks need to be treated, or they need to be left by the wayside. We move on from those feature sets, we don't incorporate them, and we keep a register, one that shows the interplay between social relationships in the development process and also the technicalities of that whole process, inclusive of the environmental rules and regulations and the law. But there are limitations in management, as we know. People don't know everything, right? Humans don't know everything. And behavioral economists will often say, but humans are rational actors. But the best we can hope for in humans is something called bounded rationality, making decisions with limited information in a limited amount of time. That's always our bottleneck, time, cost, and specification. And this is very much linked to socio-technical risk registers. So making decisions is not always rational. We're bounded in our rationality based on these limited factors and constraints that we have in our workplaces. Hindsight bias might make use of attributed blame when outcomes might not have been foreseeable. So we can say on hindsight, we should have done X or Y, or this person should have been consulted, or we should have had more users participate in the testing of the system. But consequentialist theories of ethics are hampered by a need to delimit an examination of outcomes for a given population for a given period of time. We call this the doctrine of double effect, and it's the way perhaps we may manage risks. One's actions can have multiple outcomes, positive outcomes and negative outcomes. Consequently, our limited ability to recognize and manage risk must be accommodated within what? Organizational strategies and even national strategies. A country's strategy on the adoption and release of AI matters tremendously. Similarly, organizational strategies and their internal values matter a lot. And then this mesh network within stakeholders that we call an ecosystem. But the double effect talks about positivity and negativity. Yes, the actions we take in deploying a software could have positive effects, or they may have negative effects. And let's look at this a little bit more closely. And one way to do this is to unpack it within a life cycle of stages. Now, Sullivan and Fosso-Wamba talk about 4 phases in an AI's development life cycle: the initiate phase, the build and train phase, the deploy phase, and the manage and operate phase. And in this way, responsibility can be assigned to specific entities throughout the stage of the life cycle. So decision makers are usually right at the front. They initiate. Build and train are usually the software developers. Deploy, more the commercial part of the business, incorporating users, and manage and operate. These are the people who create social contracts and services offerings, and they could be on the web, they could be on your phone, they could be on a digital device somewhere, acting autonomously, even in the environment around us. But who initiates the AI to be developed, making it available to business and government owners for adoption? Who is it? It's not the machine. It's not the software developers. It's not the users. Who is it? It's actually the decision maker. And when we talk about embedding positive intentionality in AI, that's tech for good. We're talking about whether designer or developer, entrepreneur or strategist will apply or choose to apply in the name of digital transformation of organizations and societies, and that's what matters. Each decision is value-laden. All of these people working at different places in the life cycle actually have to embrace the values of their organization and their nation state in making decisions towards positive intentionality. Each decision point and context of implementation requires the consideration of multiple stakeholder values, many of which are sometimes conflicting or incommensurable. So these are choices that are difficult for humans, especially when we clash, and our value systems are different between organizations, between organization and customers, and between nation states, one to the other. So then we can also talk about negative intentionality. So we are doing our best to include positive intentionality for positive outcomes, tech for good. But what happens when we embed negative intentionality? That's tech for not so good. And this happens every day. We see this in industry, and it's not an accident. The intentional use of behavioral engineering techniques is an example. If I want a child to use a social media application more, I embed these behavioral engineering techniques. They're called nudge factors and behavioral techniques by design. We are actively working to modify behaviors using these design methods toward things like addiction, or how someone might vote, or the kinds of preferences consumers can have. And we call these dark patterns of design. They're dark patterns with negative intentionality. And these can lead to both short-term individual problems and long-term societal problems, such things as fragmented work, impoverished social experiences, and even things like the loss of privacy. So human decision makers and ethics, what we are arguing here is that ethics is really important. An ethics of AI design and implementation that accounts for reasonable prospective and retrospective considerations. The distinction between moral permissibility and moral fault. So permissibility attributions typically occur before an action, so before the AI is conceived or unleashed and initiated. And there's an option to act at that point because you're right at the beginning of something. You haven't allowed it to take, breath and work in the field. And then there's wrongness and blame, which are part of evaluating a fault for a violation after it occurs. And that's more about the hindsight bias I was talking about earlier. But humans are responsible. Leaders in organizations are responsible. Decision makers are responsible. And they need to check their motives, their goals, and their commitments to people around them. Interestingly, in a study in the US, 62% of people were concerned about AI, but 82% indicated they did not trust tech executives to regulate AI. So there is more distrust, not among the AI, but among the executives and their decision-making capabilities to stick to regulated kinds of AI systems. So if AI is biased, blame the humans, says Payne et al. In 2023. If AI is biased, blame the humans. I'd even add there, likely blame the decision makers. So very quickly towards the end of the presentation, to allow for some questions or otherwise, moral violation attributions for human decision-making in AI are things like, was the decision maker acting in an aware state? Were they responsible? Were they intentional? Were they justified in their actions? Were they performing permissibility right at the beginning of the initiation stage? Is there blame? Is there wrongness? And these are the things that are discussed by Schenk et al. In 2019. So in the paper, I hope you have a chance to look at, we look at 3 case studies, and they're general case studies. One that looks at past violations of harm against workers through AI. We look at harm against children, cases that are going through right now, particularly with respect to nudge factors and privacy, and a future context where we look at harm against those living with disability through AI. And in all of these case studies, what's happening is a breach in regulation or a breach in international law or in rights of humans. And while we don't have time to go through each of these, the first case on monitoring workers is about surveillance through cameras, productivity scoring, ways that we surveil employers to see whether they're meeting criteria down to sometimes the seconds level, Large corporations in Europe, in particular Italy, have been fined in excess of $35 million for looking and surveilling at the practices of employees overly beyond the call of duty. In the second case, we look at the adoption of children of social media platforms and data privacy infringements that have gone into the hundreds of thousands of dollars. And here we also look at the fact that children have been used as free data annotators in some social media platforms. In the third case, a futuristic case, we'll look at how the collection of images online can be used to denote someone's genetic background potentially, whether the face can be used to denote whether someone has a particular syndrome, and whether there is informed consent in the gathering of that data. And I could tell you this is likely already happening today of the 40 billion images available on the internet. So our main discussion in the article, this is the second last slide, is on 2 points: proportionality of our response to what's going on today with AI, trying to keep a very positive future context and lens to the way we can go through design processes by embedding ethics to make the AI tech for good and not tech for not so good. We also want to bridge socio-technical gaps between actors, their interactions, the abstract language used, and the process of design. We think a lot of the design can be standardized, and we want to address the policy practice pacing problem. What we are more interested, we can see in the field, is that people want to create new technologies, but they're not so interested in regulating or behaving ethically. It's the imperative of create versus regulation, as I just said. And on the last slide, what are we going to do about this is the question. So the pacing problem has created a unique set of circumstances that have been previously encountered in fields such as biotechnology. And all of a sudden, we're seeing AI merge with things like biotechnology, vaccine creation, and the life sciences. But it's the same kind of policy practice trap. These disciplines are converging, and what we are seeing is a lag between the innovation and the regulation. So basically, the development of AI and the law. So by adopting what we call a human-centered approach to AI regulation, we not only accommodate human values, but also how users make value judgments, how they express themselves and are affected by participating in the process. So it's time to consider socio-technical risk registers. We need to consult with multiple stakeholders through the development process of an AI, but especially at the initiation stage. We need to spend more time at the beginning when we conceive and ideate about an AI as opposed to the actual solution itself. So less time perhaps programming, or at least equal amounts of times programming and designing and conceiving and ideating and matching this ideation and innovation with existing laws in our nation state, but also the values of our organization. So humans do possess agency and can take responsibility in the decision-making and make the right choice to alter the course where required of a technology that's not behaving so much in the right way. Thank you for listening.
Thank you so much, ma'am. And it was really a very, very informative session because as, technical engineering students, we are mostly teaching them more about technicalities. And this ethics somewhere, we forget to tell them a lot of times. But it's an important thing. And in our curriculum also, we have included now subjects where we have AI in ethics and all these. So I would ask the audience if anybody has any questions. Anyone from the students, if you have any questions? Or those who have joined online, if you have any questions, you're most welcome to ask. So at the lower levels, we have seen where people are making memes out of this generative AI videos and they're transforming. So that is also some kind of, not so good AI where people are making videos with faces and everything. You're muted, I think.
Yes, I'm listening very carefully, and I think the students are aware of these deep fakes and disinformation and the memes, and a lot of them have to do with politicians and high-profile figures now that are supposedly enemies. But these generative AI memes are quite clever, quite funny. But it actually, when you start thinking about it, how they could be incorporated. So AI friend or foes, the way that it's being positioned, it's this dual-use technology. I can use it to defend against deep fakes by using AI to detect that this image is a deep fake or I can use it to create deep fakes. So this is the kind of paradox situation we are in, but this is the same for all technologies. It's just that AI has this additional power. So if we do not regulate to a degree these things, I'm not saying the jokes and the humor can't be occurring in our world. That's very important, I think, in the world to have humor, but it just is testament to the fact of what we might be able to do. And I think students, as you get into the workplace, you will hear about legal cases. There have been about 5 just this year of millions of dollars being passed through deep fakes on Zoom. So an employee thinks they are talking to their boss, the executive director, and they are the executive director, who's really a deep fake, is asking for money to be transferred between bank accounts. Well, there are 5 legal cases in Mongolia, in China, in Chile, in Peru, in different places that are showing us that this is now becoming quite serious. So if we don't espouse ethics, and of course, thieves will not espouse ethics, they are acting unethically, on purpose, deliberately, intentionally. We call that negative intentionality. But what can we do with technology to use technology against these things to allow AI and generative AI to flourish and be good, to support us in our learning and our development as human beings and in our existence? The only thing we're seeing there, another negative, of course, is the environmental impact and sustainability impact. The amount of electricity required to power these generative AI systems is quite substantial when we are all now using transactions to request data from these engines. So I think that's a wonderful reflection on your part.
Thank you, ma'am. Once again, on behalf of School of Computer Science and Engineering and myself, Professor Akansha Singh, I thank you once again for such an informative session. And definitely when you visit India, please do visit our university. We'd love to have you on campus.
I would love to. And students, thank you. May you have a wonderful meeting, and thank you for putting on this amazing event, which has attracted so many wonderful speakers. Have a beautiful rest of day.
Thank you. Thank you so much. Bye.
Bye-bye.
Bye.